How do they know? Every day we drink beverage and claiming to be rich in the vitamin C. But have you wondered how they are actually measured? So, in this video, we will explore how to determine amounts of vitamin C in apple juice using theory, method, and calculation example. Let's go! Hi, so I'm Afi. So in this video, we will explain about the volumetric analysis. So for the introduction, volumetric analysis is also known as the titrometric analysis, or simply titration is a quantitative chemical analysis method used to determine the unknown concentration of a specific substance like the aldehyde by reacting it with a solution of known concentration. Then the core principle relies on measuring the exact volume of the titrant required to completely react with the aldehyde according to a specific chemical equation. Now, I will pass to Zafir for the next slide.
On this slide, I will explain the theory of a volumetric analysis. Volumetric analysis is a quantitative analytic method that uses titration to determine of a substance in solution. In this experiment, a redox titration is used, which involving oxidation and reduction between chemical substance. On this slide, show the redox reaction between ascorbic acid, which is vitamin C, and iodine. The chemical equation is ascorbic acid plus iodine will produce dihydroascorbic acid plus hydrogen ions and iodide ions. In this reaction, ascorbic acid loses electron and is oxidized to dihydroascorbic acid, while iodine gains electron and is reduced to iodide ions. The purpose of this titration is to determine the concentration of vitamin C in the sample such as fruit juice or tablet. Ascorbic acid acts as the reducing agent, while iodine acts as the oxidizing agent. Starch is used as an indicator. The endpoint is reached when the solution changes to the blue-black color, showing the excess iodine has reacted with the starch, and all the vitamin C has been consumed. And now I passes to Anas to talk about methodology.
Now, let's move on to the methodology. The first thing we need to know is the apparatus. The first one, we need two 100 ml volumetric flask, one 400 ml beaker, two 100 ml beaker, one 100 ml conical flask, 100 ml burette, and 100 ml measuring cylinder. And for the add-on apparatus, we need 10 ml syringe, dropping pipette, spatula, funnel, and marker pen. And for the chemical, we need 1% ascorbic acid or vitamin C, DCPIP, and distilled water. This is step-by-step procedure for the vitamin C titration. The first one is safety and equipment setup. Wear your personal protection equipment or PPE as directed by your lab assistant and gather all your necessary equipment. Second step of this experiment is prepare the 1% vitamin C or ascorbic acid solution. Weigh out 1 gram of the ascorbic acid and add 100 ml of distilled water to the acid. Next, you pour the solution into a 100 ml volumetric flask. Make up the solution to the graduation mark. You can invert the flask to ensure all solid is completely dissolved. To prepare the 0.1% DCPIP solution, first step is weigh out 0.1 gram of DCPIP. Add a small amount of distilled water to the DCPIP in a 100 ml beaker to begin a dissolving process. Transfer this to a 100 ml volumetric flask and fill with distilled water up to the graduation mark. After that, we need to prepare and condition the burette. Rinse the burette by adding a small amount of the prepared vitamin C solution. inverting it to coat the site and then disposing of that solution. Fill the burette with the vitamin C solution to a point above the zero mark. Allow the excess solution to flow through the tip until the bottom of the meniscus rests exactly on the zero graduation. Afterward, we need to prepare the conical flux. We need to pipette 25 ml of the prepared DCPIP solution into the 100 ml conical flask. Afterward, we need to prepare the conical flux. We need to pipette 25 ml of the prepared DCPIP solution into the 100 ml conical flask. Lastly, we need to perform the titration. Slowly add the vitamin C solution from the burette into the conical flask containing the DCPIP. Continue adding the solution and swirling the flask until the deep blue color of the DCPIP disappear and the solution become colorless. The last step is you need to record your result. We continue to Daniel to elaborate more about the calculation step.
Now we are at example calculation part. This is the data that we obtained from Google. Let's say we have iodine with molarity of 0.005 mol per liter, volume of juice in flask 10 milliliter, and average volume of iodine from the experiment, which is 12.43 milliliter. As we know, the chemical equation for titration of vitamin C shows that mole ratio between iodine and vitamin C is 1 to 1. In this experiment, we need to calculate the mass of vitamin C in the 100 ml apple juice. This is the step-by-step calculation. First, we need to identify the moles of iodine used. We multiply the molarity of iodine with the average volume of iodine used in this experiment, and then we will get 6.215 times 10 to the power of negative 5 mole of iodine. Second, we need to identify the moles of vitamin C, and since the ratio between vitamin C and iodine is 1 to 1, so we will get the same number of mole, which is 6.215 multiplied 10 to the power of negative 5 mole. Step 3, we need to identify the mass of vitamin C in 10 milliliter juice. We need to multiply the mole of vitamin C with its molar mass. The molar mass is 176.12 gram per mole. And after the multiplying, we will get 10.9 milligram as the answer. And lastly, to determine the mass of vitamin C in 100 milliliter juice, we need to multiply the mass that we just get with 10. And then we will have 109 milligram vitamin C per 100 milliliter apple juice. So that's all for the calculation from me. I will pass it to my friend Nasrullah to conclude what we have learned today.
Analytical chemistry is a branch of chemistry that focuses on the identification and quantification of chemical substance in a sample. This field encompasses the use of classical methods such as extraction and gravimetric analysis, as well as modern instrumental techniques including spectroscopy, chromatography, mass spectrometry, and electrochemical methods. In addition, analytical chemistry involves data analysis and chemometrics to ensure that the results obtained are accurate and reliable. The applications of analytical chemistry are extensive, covering areas such as nutrition, medicine, forensic science, agriculture, and environmental science. Therefore, analytical chemistry plays a vital role in helping scientists obtain accurate information about the composition of substance and support the advancement of science and technology in the modern world. That's all. Thank you.
Now we know how volumetric analysis play a crucial role in ensuring nutritional content is accurate. It's